Ever wondered how AI can actually understand both images and text the way humans do? Like really reason about what it sees? That's the big challenge vision language models, VLMs, are tackling. And today, we're diving into a breakthrough that's rewriting the rules of multimodal reasoning. Meet GLM-4.1V-Thinking, a new AI system that's not just seeing images or reading text. It's learning to think with both, combining them to tackle complex tasks that require real-world logic. So how does it work? Let's start with the basics. Traditional AI models can identify objects in photos or translate text, but they struggle with tasks that mix visuals and logic, like solving a math problem from a diagram or understanding a video's timeline. GLM-4.1V-Thinking isn't just seeing or reading. It's building a bridge between the visual and linguistic worlds, learning to connect what it sees with what it understands. Here's the secret sauce: reinforcement learning with curriculum sampling, RLCS. Think of it like a personalized study plan for AI. The model starts with simple tasks, like identifying basic shapes, then gradually tackles harder challenges, like solving equations from diagrams. It learns by trial and error, getting feedback to correct mistakes, just like a student improving with practice. But raw data isn't enough. The team behind GLM-4.1V-Thinking didn't just throw billions of image-text pairs at the model. They curated the data with care, using tools like Clip to ensure every image and caption match in meaning. They also balanced the data to avoid biases, making sure the model isn't just stuck on popular trends, but can handle niche topics too. The results? This model is a powerhouse. On 23 out of 28 benchmarks, it sets a new state-of-the-art, especially in STEM, science, tech, engineering, OCR and chart analysis and video understanding. It even beats bigger models like QN2, 5VL72B, and GPT-4o on critical tasks like diagram analysis and math problem solving. And here's the kicker: it's compact, just 9 billion parameters, but it's packing a serious punch. But here's what's really cool: the model's ability to generalize. Training on one type of task, like STEM problems, actually boosts performance on others, like visual grounding or GUI interactions. It's like learning to read a map helps you navigate a new city. Skills transfer across domains. So what does this mean for the future? It's a big step toward AI that can truly reason with both visuals and text. Whether it's analyzing scientific diagrams, understanding videos, or even helping us solve complex problems, this tech is pushing boundaries. Now let's talk about the hidden challenges in making AI truly smart. AI learns through trial and error, like a student who guesses answers instead of studying. It might get the right answer, but the reasoning, not so great. Imagine solving a math problem by flipping a coin instead of using a formula. Current systems often just check if the answer is correct, not how it was reached. That's a problem, because it could accidentally reward bad thinking. Then there's instability. Small changes in training can make AI swing between being super detailed or totally vague. It's like a student who either overexplains or gives a one-word answer depending on the day. And when faced with tricky scenarios, like blurry photos or crowded scenes, it might just guess instead of analyzing properly. So what's next? Researchers are building better judges for AI, systems that check how models think, not just what they say. They're also testing if training with visual tasks, like decoding code and images, can make text-only tasks smarter. And as models improve, we'll need tougher tests to catch errors like shortcut thinking or hallucinations. This isn't just about building smarter AI, it's about making sure those systems think the right way. Now imagine a library where every book has both text and images, all linked together. That's Omnicorpus, a 10 billion item dataset designed to teach AI how to connect words and visuals. Think of it as training AI to read the room, not just memorize facts. Why does this matter? Traditional AI struggles to ground abstract concepts in real-world data. If you ask it to find a red apple in a basket, it needs to link the word apple to its image and red to its color. Omnicorpus forces models to learn these connections at scale, paving the way for smarter systems. But here's the kicker: this isn't just about data. Researchers used advanced algorithms to ensure the dataset is balanced, diverse, and free from biases. It's like teaching AI to understand the world through both sight and language. And the results? Early tests show models trained on Omnicorpus outperform previous ones in tasks like captioning, object recognition, and even. Let's shift to real-world applications. Take code. Understanding pointers isn't just about syntax, it's about memory management. When checking if a word is a palindrome, setting left equals 0 and right equals len s1 ensures the algorithm scans the entire string, avoiding edge cases. It's a tiny detail with massive implications for reliability. In chemistry, molecular groups like nitriles, CN, act as functional fingerprints. A molecule with a carbon double bond, ester, and nitrile might behave unexpectedly, like a polymer that repels water despite esters typically being hydrophilic. These subtle interactions shape material properties in ways that demand precise modeling. And in math, proving geometric relationships requires rigorous logic. Showing two planes are perpendicular by demonstrating a line is perpendicular to both is like using a protractor to verify a right angle. Calculating a sphere's center within a pyramid involves coordinate geometry and vector analysis, tools that transform abstract concepts into solvable equations. So what's the big takeaway? Problem solving isn't about magic, it's about breaking things down. Whether it's code, chemistry, or math, it's about asking, what's the simplest way to check this? Or what rules apply here? These examples show how logic and creativity work hand in hand. Next time you face a challenge, remember, even the toughest problems can be unraveled with the right approach. Thanks for watching. Hit subscribe for more deep dives into science, tech, and the curious minds behind them.